Section for proving triangles are congruent using angle-side-angle and angle-angle-side congruence postulates. The angle-side-angle congruence postulate says that if two angles and the included side of one triangle are congruent to two angles in the included side of another triangle, then the two triangles are congruent. Just like yesterday when we had talked about the side-angle-side, this is kind of the reverse of that. Now we have angle-side-angle. The important word here is included side. So angle-side-angle means that you're going to know a side length, and then you're going to know the two angles on either side of that side length. So the side has to be between the two known angles that are congruent to two angles of another triangle. The angle-angle-side congruence postulate says that if two angles in a non-included side of one triangle are congruent to two angles in the corresponding non-included side of another triangle, then the two triangles are congruent. So in this case, I'm going to have two consecutive angles and then a side that is not included that is going to be congruent to another triangle's two angles and the corresponding non-included side. So in this case, my side is not going to be between the two angles that are known. This asks, is it possible to prove that the triangles are congruent, and if so, state the postulate or theorem? In example A, notice I'm given that angle C is congruent to angle F and angle G is congruent to angle E. I could also say that the two angles in the middle, angle CDG and angle EDF, are congruent because they're vertical angles. However, I know nothing about any of these sides. It doesn't tell me that any of these sides are congruent to a side of the other triangle. So in this case, I am not going to be able to say that the triangles are congruent. There is no congruence postulate. I'm stressing the word congruence. So there is no congruence postulate that says if you know the three angles of one triangle are congruent to the three angles of another triangle, then the triangles are congruent. So A, we do not have enough information. It is not possible. For B, notice that we're given the two angles KHJ and angle HJI are congruent, and we're also given angle IHJ and angle HJK are congruent. If you notice, the two triangles that are shown are sharing the side HJ, the diagonal line going through what looks like a parallelogram. Because they are sharing the side HJ, the reflexive property says that HJ is congruent to HJ. So I can use the angle-side-angle congruence postulate to say that these two triangles are congruent. Notice it is angle-side-angle because the known side that is congruent between the two triangles is included between the two angles that we know are congruent in the two triangles. The next example says that we are given that angle B is congruent to angle C and angle D is congruent to angle F. It also tells me that M is the midpoint of DF. We're asked to prove that triangle BDM is congruent to triangle CFM. The first thing we need to start our proof with is what we know, or what we are given. So I'm going to go ahead and rewrite angle B is congruent to angle C, angle D is congruent to angle F, and M is the midpoint of DF. If we know that angle B is congruent to angle C and D is congruent to angle F, that's great. To prove that the two triangles are congruent, however, we're going to need to know something about a side. We could either use angle-side-angle and know that BD is congruent to CF, but I have no way to say that BD is congruent to CF based on anything that I'm given or the diagram. We could also use angle-angle-side and say that DM is congruent to MF. If you look, that is going to be an option because it tells me in my givens that M is the midpoint of DF. By the definition of midpoint, a midpoint cuts a segment into two congruent parts, I can say that DM is congruent to MF because of the definition of midpoint. If you notice, if I were to put a tick mark on those two sides, DM and MF, I can now say that the two triangles are congruent because of the angle-angle side congruence postulate. The next example, we are given that WZ bisects angle XZY and angle XWY. We're asked to prove again that the two triangles are congruent. Always start with what you're given, so I'm going to put that WZ bisects the two angles because the reason is that it was given. If you think of the definition of an angle bisector, we know that an angle bisector is going to cut an angle into two congruent angles. Because we are given that WZ is a bisector of these two angles, I can go ahead and I can say that XZW is congruent to YZW, and I can say that XWZ is congruent to angle YWZ, and the reason is the definition of angle bisector. If you notice, we are given, if you drew this diagram on your paper and you marked the congruent angles that we just said, you would notice that a segment, ZW, is included between my two known angle measures. Because it is included between, and because the two triangles are sharing side ZW, I need to go ahead and say that ZW or WZ is congruent to WZ, and that is just the reflexive property of congruence. Any segment is going to be congruent to itself. Because that segment is included between the two angles that I used the definition of angle bisector to say were congruent, I can go ahead and say that the two triangles are congruent because of angle side angle. The next example says in the diagram, segment AB is parallel to segment DE, and segment AB is congruent to segment DE. We are asked to prove that triangle ABC is congruent to triangle EDC. First, let's start with what we're given. So I'm going to rewrite that AB is parallel to DE and AB is congruent to DE. We've done proofs before with triangles, and I've told you anytime that you are given that two lines are parallel, you should be thinking transversal. There's actually two very valid ways to write this proof and prove that the two triangles are congruent. I'm going to do it one way, and then I'll try to describe to you how you could do it the other way. But there is not one right answer here at all. There's two very, very valid ways to do it. I'm going to choose to use the fact that angle ACB and angle DCE are vertical angles, and because they are vertical angles, I can say that they are congruent. So I'm going to go ahead and say that ACB is congruent to angle DCE because of the vertical angles theorem. Now I'm going to use the fact that we have a transversal, and I am going to say that angle B is congruent to angle D because of the alternate interior angles theorem. If you notice, the segment BD would be cutting through, or it would be a transversal to my two parallel lines AB and DE, and because of that, I can say that and because they are alternate interior angles, I can say that they are congruent because of the alternate interior angle theorem. If you could mark that on your paper, you would see that I have angle side. So I can say that triangle ABC is congruent to triangle CDE because of the angle side congruence theorem, or postulate. Now, the other way that I could do this is I could not use the vertical angles theorem, and I could because of the alternate interior angles theorem, I could say that angle B is congruent to angle D, and I could say that angle C is congruent to angle E. Both of those would be using the alternate interior angles theorem. If I chose that route, then I could say that the two triangles are congruent because of the angle side angle congruence postulate. So two very valid ways, and there's even a couple of other ways that you could do it. However, either way is valid. Either way, you should be thinking using alternate interior angles theorem or something having to do with a transversal. A big red light or a big flashing light that should point out to you that you're going to be looking at a transversal is the fact that they tell you you have parallel lines. Anytime they tell you that you have parallel lines, you should start to think transversal. Today's assignment is on page 223. It's numbers 14 through 20 and number 22.